Okay, let us begin this class and finish it fast. Okay. Uh, in the morning class, I was talking about the directive influence of substance on the benzene ring. So today I will now in this afternoon class, I told you in the morning that I will be discussing about benzene. Okay, so benzene, as you know, uh, what do you call? It is an simplest and the most important arene. Benzene, it is the simplest and the most important arene. Most important arene. Now, this benzene is also regarded as the parent hydrocarbon. It is regarded as the parent hydrocarbon of aromatic compounds. Aromatic compounds. Now, after this introduction to benzene, let me explain you the laboratory methods. In fact, let me write and explain you the equations pertaining to the lab preparation of benzene. So, for the preparation of benzene, the first method, the first one. I'll write it down as laboratory method. Laboratory method in the lab, how to prepare benzene. Okay, by using which chemicals. So, in the laboratory, we can use the following reactions. Number one, from sodium benzoate. From sodium benzoate, you can obtain benzene from sodium benzoate by reacting this sodium benzoate COONE C6H5. Sodium benzoate, it is reacted with soda lime. It is reacted with soda lime, that is a mixture of sodium hydroxide and calcium oxide, and the reaction mixture is heated. Reaction mixture is heated. So when you do that, over here there is a decarboxylation reaction happening when this Na2CO3 is expelled. Na2CO3, both the sodium and CO3, it goes out. This goes out. Na2CO3, and then this hydrogen links on this carbon to give us the benzene. This is benzene, and the side product is sodium carbonate. Now, this is how we obtain benzene from sodium benzoate in the lab. Okay, this is number one, subpart one. Okay, now after this, number two, we go to the next slide, subpart two. The next lab preparation, we can also obtain benzene from phenol, PHENOL, phenol. To obtain benzene from phenol, this phenol, it is distilled by using zinc dust. Zinc dust. So phenol, when it is heated in the presence of zinc dust, this reaction is called distillation. It is called distillation. So this zinc, it is going to remove the oxygen from here. Okay, hydrogen rearranges and goes over here only. So we are left with benzene, and zinc oxide is formed as the other product. That is the second method of preparation of benzene. The next one, number 3, is from sulfonic acid, from benzene, benzene sulfonic acid, benzene sulfonic acid. Now to prepare benzene from benzene sulfonic acid, the benzene sulfonic acid is boiled, it is boiled with concentrated hydrochloric acid at a temperature range of approximately 423 Kelvin. This is a, it is a hydrolysis reaction. It is a hydrolysis reaction. So here the benzene sulfonic acid, the formula is here, SO3H. This is benzene sulfonic acid. It is boiled, means what has to be there for boiling to happen, and the temperature range is 403 to 423 Kelvin, okay, in the presence of concentrated hydrochloric acid. So when this is done, the reaction, it is, I told you, it is hydrolysis. Hydrolysis. So hydrolysis happens, and then we get benzene, and along with benzene we get sulfuric acid. So an inorganic acid is obtained. Okay. So this was the third method for the preparation of benzene in the lab. After that, moving to the next method, that is number 4, from a very important chemical, from benzene, benzene diazonium chloride. Diazonium chloride. Benzene diazonium chloride is a very, very important chemical in organic chemistry. The formula of benzene diazonium chloride is here, N2 plus Cl minus, and then the benzene ring. Okay. This benzene diazonium chloride, it is prepared by reacting aniline with sodium nitrite, NaNO2, at ice cold temperature. Okay. So this benzene diazonium chloride is prepared in situ. In situ. Whenever it is required, it is prepared and then it is used. So as soon as benzene diazonium chloride is obtained by the reaction of aniline with sodium nitrite, NaNO2, at ice cold temperature 273 Kelvin, it is reacted with alcohol, that is ethanol, CH3CH2OH. Okay. When we obtain benzene as the first important product, along with this, after that we obtain an aldehyde, CHO, acetaldehyde, plus nitrogen plus HCl. So this is the reaction from benzene diazonium chloride. This is the fourth method of preparation of benzene in the chemistry lab. Okay, by using benzene diazonium chloride. So remember, benzene diazonium chloride is prepared in situ by reacting what? By reacting aniline. By reacting aniline. This is aniline. This is aniline with sodium nitrite at a temperature of 273 Kelvin, that is 0 degrees Celsius. So when this reaction is done, and that's how we get what you call benzene diazonium chloride, N2 plus Cl minus, this is benzene diazonium chloride. Okay, so this is the required chemical substance which is necessary for preparation of benzene by reaction with an alcohol. The alcohol used is ethanol. After that, the next method of preparation of benzene is number 5, that is from ethyne. From ethyne. From ethyne or acetylene. Now we can also obtain benzene, which I have discussed in the previous classes. If we take three molecules, three molecules, ethyne, 3CH, triple bond CH, okay, and you pass it through a hot iron tube at 673 Kelvin, under pressure. So it's undergoes cyclization reaction with the benzene C6H6. This I have done in the previous class also. So these were the methods. This is normally called synthesis synthesis of benzene from an unsaturated hydrocarbon, that is ethyne. Okay. So after this, we can also obtain benzene. We can also manufacture benzene from coal tar or from coal gas. The chemical reactions for that is not required over here. Okay. So remember, we can manufacture a benzene on a large scale from two things. The manufacture of benzene is done from two things over here. From one is from coal tar, another one is from coal gas. Coal gas. Now the method which is applied over here generally it is called we use apply several methods, but the principal important method it is fractional distillation. So distillation of coal tar. Okay, and similarly, same thing happens in the case of using coal gas also. Okay, so these were the important methods for the preparation as well as manufacture. For the manufacture, they don't have any chemical reactions. Just remember, you can obtain benzene from coal tar and coal gas by a method which is employed over there to separate the various components of coal tar and coal gas and get distilled benzene from over there. After that, physical properties of benzene. Physical properties. Physical properties of benzene. If you look at the physical properties of benzene, we know number one, it is what? It is a colorless liquid. Colorless liquid. It is a colorless liquid having a smell, a characteristic peculiar smell. It has a characteristic odor. It has a characteristic odor, a distinct odor. First physical property. Then the next one is boiling point. Boils. Boiling point is around 353.1 Kelvin. Okay. Now this within it solidifies at 0 degrees Celsius. It solidifies at 0 degrees Celsius or to approximately 0 to 5, we can say 278 Kelvin, 0 to 5 degrees Celsius, or 273 Kelvin to 278 Kelvin. So if we are doing chemistry practicals, organic chemistry practicals in places like Darjeeling or cold temperature zones, then in the chemistry lab, the liquid benzene which is stored over there, it will be available in the solid form. It is a white crystalline solid. It looks somewhat similar to sugar crystals. Okay. Then the third physical property of benzene, it is insoluble in water. Remember that. It is insoluble in water. It is insoluble in water, but miscible with alcohol. But it is miscible, means soluble, but miscible in alcohol. Alcohol, when I say alcohol, it has to be ethanol, alcohol, and dimethyl ether, diethyl ether, propyl methyl ether, in all proportions. In all proportions, it is solubility is this one. The number four, benzene. It is a good solvent. Benzene itself is a good solvent. Benzene is a good solvent. It is a good solvent for fats, animal fats, okay, resins, sulfur iodine, sulfur iodine. It is a good solvent, and many more organic compounds are there which can be easily dissolved in benzene. Now, the fifth physical property is benzene. If you put benzene in a spirit lamp containing a wick, this benzene will burn with a luminous sooty flame. It burns with a burns with luminous sooty flame. Sooty flame. Sooty flame means the flame, if you place an object above the flame, that object becomes stained black. Black deposits are seen on the surface, exposed surface to the flame. The next property, that is number 6, the sixth chemical property. Let me introduce one more slide over here. The sixth property is important. Okay. Now, benzene vapors, don't smell vapors of benzene. The vapors of benzene are toxic in nature. They are what? They are toxic in nature. And if you inhale them in large quantity, it will kill you, of course, but little bit goes in a system. Okay, depending upon the parts per million over there, then it can make somebody unconscious also. Unconscious. Okay, and that can be, life threatening. Okay, so you have to avoid inhaling vapors of benzene. Okay, so these were some physical properties in the preparations already discussed with you. Okay, now after this, my dear students, let us move ahead in this chapter to some chemical properties. Let me tell you before going to the chemical properties. Now, benzene, as you know, in spite of having three double bonds in the ring, it has three double bonds, alternate single and double bonds in the ring. Okay, it is quite stable. Because of this, it is stable. Stability is higher. But if you compare this benzene with alkenes, alkenes reactivity is high. Alkynes also reactivity is high. Okay. So unlike alkynes and alkenes, the reactivity of benzene is less. So it is this is because there is resonance. There is delocalization of these pi electrons in the benzene that makes it what quite stable and unreactive. Now we can perform the chemical reactions on benzene by providing certain temperature, pressure, use of catalyst. Okay, then only the reactions are possible. Normally, we know benzene undergoes reactions, addition reactions. They can undergo substitution reaction normally. These are the main reactions which are undergone by benzene. It undergoes addition reaction, substitution reaction, even oxidation reactions are also observed in the case of benzene. So this is what we are going to discuss in the next slide. Now, if you look at the next slide, the first one, it's named over there electrophilic substitution reaction. So the very word which you see over there, it is substitution reaction. So this is the first type of reaction which is undergone generally by benzene. Now here some electrophilic substitution reactions of the benzene or arenes are given below. So halogenation is the first one. Now benzene reacts with halogens in the presence of a Lewis acid. Lewis acid is aluminum chloride, AlCl3. AlCl3 is the Lewis acid. Okay. Now how to make it a Lewis acid? So what happens? The chlorine molecule interacts with the aluminum chloride AlCl3 and produces a chlorinium ion Cl plus ion and AlCl4 minus. So the halogen is being carried over here. So it is behaving like the halogen carrier. Halogen carrier. Halogen carrier. It's carrying a negative charge. It is carrying a negative charge. So that's how it is behaving as an what do you call generating negatively charged species. It may be a nucleophile, but this one is the electrophile. This one is the electrophile. So that electrophile is remarkably important whenever we want to react benzene with chlorine. So here it is an electrophilic substitution reaction happening. So look at the equation: benzene plus Cl2 in the presence of Lewis acid, aluminum chloride. We get to see formation of chlorobenzene. Now try to understand this mechanism over here. Immediately chlorine will not react with benzene directly. First, this chlorine has to react with aluminum chloride, which is the Lewis acid, to produce a halogen carrier. and liberate the electrophile, that is Cl plus. And now after that only this Cl plus is going to kick out the hydrogen which is present there on one of the carbon atoms and take its place and form chlorobenzene. This reaction clarifies that the role of Lewis acid. It is used in the above reaction to generate the desired electrophile. So what is the function of Lewis acid? The Lewis acids are generally used to, generate or produce the electrophile which is required to carry out the successful halogenation, or here in this case it is chlorination. Okay, so this reaction becomes important. Okay, halogenation of benzene using Lewis acid. Lewis acid. Okay, then after that, if you see on the screen, the next slide for you over there, it is nitration. Okay, NO2, production of NO2. It is also an electrophile. So here also it is a case of substitution reaction. So benzene, on if you heat benzene with a mixture of concentrated nitric acid in the presence of Kong sulfuric acid, okay, it produces nitrobenzene. Now let us first understand the mechanism of the generation of nitronium ion. This NO2 ion is called nitronium ion. So how to generate nitronium ion? Have a look. This sulfuric acid, this hydrogen is taken away by this oxygen of the nitric acid, and then this part leaves, it goes away in the form of water, minus water from the ion which is produced. So leaving with us only NO2 plus, like this. Water is left and we have got nitronium ion. Now this nitronium ion is acting as the electrophile over here, and then it is replacing the hydrogen which is present on the carbon atom in the ring. So it is producing nitrobenzene. So this nitration is also an example of substitution reaction. Substitution reaction by an electrophile. Okay. Now after that, moving to the next what you call electrophilic substitution reaction. On your screen we have, after nitration we have sulfonation by sulfuric acid. So if you use only concentrated sulfuric acid reacting with benzene molecule, then sulfuric acid, you have seen on the previous slide, sulfuric acid is HO3SOH. HO3, it is HO3SOH. So this SO3H part, this SO3H part, this is going away, OH is going away with the combining with the hydrogen from the carbon atom to form water, and this part is replacing the hydrogen. Okay, and it is taking that place to form sulfonic acid. This is called benzene sulfonic acid. Okay, the benzene sulfonic acid is an important compound for the preparation of, you have already seen in the previous slides, it is used to prepare benzene also. Okay, now that is sulfonation. Now by using, now after that, benzene, we can use benzene or its homologues on treatment with alkyl halides like methyl chloride in the presence of anhydrous aluminum chloride, okay, to produce alkyl benzene. So benzene, if you react with methyl chloride in the presence of aluminum chloride, okay, the purpose of aluminum chloride, the Lewis acid, it is to generate an electrophile, that is CH3 plus. Okay, so again it is an electrophilic substitution reaction. Okay, electrophilic substitution reaction in a molecular. Okay, so it is forming toluene. This is methyl benzene, which is called toluene. Toluene, toluene also. Okay, so how to generate the electrophile, that is methyl ion. This is the process over here. So this Cl is gone over there, taking both the electrons from here with AlCl3 to give AlCl4 minus charge, and there is a electrophile CH3 plus. Okay, carbocation. Now this carbocation is effective in going and replacing the hydrogen from here, from any one of the carbon atoms, to produce toluene or methyl benzene. Okay, then after that we can see on the screen the next reaction is Priddle's Friedel Crafts acylation, acyl chloride, acetyl chloride. Look at this, acetic anhydride. This is acetyl chloride. Okay, so here this part, this part is forming the electrophile over here, and this is going with the aluminum chloride, the Lewis acid. Okay, to form AlCl4 minus. Okay, mechanism is here already. See, have a look at this. It is generating the electrophile CH3C plus O. Okay, which is forming acetophenone in this case with acetic anhydride. Here also it is forming acetophenone with the acetyl chloride. Okay, so this is called Friedel-Crafts acylation. Introduction of an acyl group, acetyl group. It is called Friedel-Crafts acylation. Introduction of an alkyl group. It is called Friedel-Crafts alkylation. So whenever it is Friedel-Crafts, remember we always use anhydrous, anhydrous aluminum chloride, okay, which is used to generate the required electrophile. Okay, after this, moving to the next slide, you can see over there addition reactions. Now after the substitution reactions, in short, okay, we have next type of reaction undergone by benzene and or arenes. It is called addition reactions. Now for the addition reactions, the first one which you can see on the screen is formation of cyclohexane. Now if you hydrogenate benzene, the hydrogenation of benzene at high temperatures, that means giving hydrogen, addition of hydrogen, which is called hydrogenation, in the presence of pressure, and as well as a catalyst like nickel. The nickel is the best catalyst in this purpose. So there is addition of what we call hydrogen. So all the pi bonds are broken into single bonds, okay, and then it is being added by hydrogen to give a compound that is called cyclohexane. Okay, cyclohexane. All carbon atoms to like this, cyclohexane, CH2, 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 here also CH2, here also CH2, here also CH2. So this is the cyclohexane I'm talking about in this formula. Okay. Now, mm, now there is another one, formation of BHC, BHC, benzene hexachloride. Now BHC is called gamexine. You know, if you have been used to what you call this agriculture and all, if you have been to the agricultural farmlands and all where they do cultivation, plantation of various crops, you will find that the farmers they use gamexine is an you can say it's an anti, it's repelling ants, it repels ants. Okay, it kills or chases away the ants. The ants, they will destroy the crops, no? So this gamexine, which is used as an, you can say, insecticide for the purpose of chasing away ants or killing the insects or chasing the insects away from the plants. Otherwise, the plants will get destroyed. So here we can use benzene and react benzene with chlorine gas in the presence of ultraviolet light, that is diffuse sunlight at some temperatures around 273 what do you call this, 500 Kelvin, that is double of that, 543 degrees Celsius, 500 Kelvin, to produce benzene hexachloride. Instead of the 6 hydrogens, we are adding 6 chlorine atoms or to each of the carbon atoms in the benzene ring to produce this benzene hexachloride. So next time if you go to one of the shops, horticulture shops in Kalimpong, on the main road there is a shop which is called Singh's horticulture shops. Okay, shop in the main road just opposite to the police station. Then you ask for gamexine, that is the common name. Okay, it is called gamexine. They will give you chemically, they will give you BHC, the correct chemical name, benzene hexachloride, and it is used for spraying. It's like a powdery substance, ash colored powdery substance, which is sprayed, which is just sprayed by using your hands, or kind of like, of course you have to wear gloves to spray this powder on the soil where you have done the plantation, so that the soil all the insects, any ants available, they are chased away, and the crops and the plants are protected from their attack. Okay, so that is one addition reaction. So this is the first addition reaction, this is the second addition. So you must have noticed over here that Addition reactions of benzene, it happens with some difficulty. It happens with, they undergo addition reaction, but they are forced to undergo addition reaction because we're using temperature over here. We're using temperature over here also. Okay, so certain conditions are required to be met, fulfilled by benzene in order to undergo addition reaction. Okay, now the next reaction which I would like to discuss with you all in the case of addition reaction of benzene, it is called ozonolysis. This is not given there in the slide. So this one, it is called ozonolysis, addition of ozone, addition of ozone. Okay, this I have picked out specially because this reaction may be important. So now for the addition of ozone, to explain this reaction, I would like to draw the structural formula of benzene in this manner. Have a look very carefully. CH, HC, then CH, then again double bond, CH, then this side I'll put CH, double bond, then CH, then over here single bond. So now I'll introduce ozone. So ozone, since there are three triple bonds over here, we will need three molecules of ozone. This is ozone. Okay. Now these three molecules of ozone, they link. They try to disturb the multiple bonds, the carbon-carbon multiple bond, that is double bonds, and they form a structure like this. They form a triozonide. They produce a triozonide. Have a look at this structure. CHO, CH. Okay. Then over here there is one oxygen. There is one oxygen like this. So one ozone is fitted over there. Okay. Similarly, this single bond, again CH, over here oxygen, over here oxygen, over here oxygen, then over here again CH, and then bond over here. So this is another ozone over here. One, two, three. Again this over here, CH, oxygen, oxygen. Okay. Then over here CH, and over here we can have one like this, and these are linked to each other like this. So that is how the ozone molecules disturb the double bonds present in benzene. Okay. Now this product which is formed, it is a triozonide. It is a triozonide. What type of compound? It is a triozonide. After this, it is an unstable compound, of course. So upon hydrolysis, if you subject this to addition by using water, if you hydrolyze this, hydrolysis in the presence of water, of course, three molecules of water, you have to break the bonds. So it will undergo, you know, breaking in this manner. It will undergo breaking in this manner over here. Like this, it will break over here one part. Another part breaks straight away like this. Okay, it breaks like this, and there's one more part breaking like this. Okay, so this breaking produces aldehyde molecules. Have a look at this. Aldehyde, glyoxal, two carbon atoms. There are one carbon atom. Here also two carbon atoms. Here also two carbon atoms. So it is producing total three molecules of an aldehyde, that is called glyoxal. CHO plus, it produces hydrogen peroxide. Okay, upon hydrolysis, this compound is called glyoxal commonly. Glyoxal. Glyoxal commonly. The correct IUPAC name becomes uh, it it in dash 1,2 dial. It in 1,2 dial. It is an aldehyde. So this addition of ozone to benzene is important. Okay, so remember the intermediate which is formed. It is an ozonide. It is called benzene triozonide. It is called benzene tri triozonide. Benzene triozonide. So there is a question hidden over here for multiple choice also. Okay, so I can ask you the question. Ozone, when reacted with benzene, it produces an intermediate compound which is an aldehyde. So choose the aldehyde. So I can give various options. I can give formaldehyde, I can give acetaldehyde, I can give glyoxal. Okay, I can give glycerol. So you have to choose from there. So your answer has to be glyoxal. Okay. Now I can ask you another question from here also. When benzene is reacted with ozone, okay, then the the first product which is formed, what is the product? What is the product called? So you can ask, there can be four options. It can be benzene monoazonide, benzene triazonide, benzene tetraozonide. So you have to choose the correct option as benzene triazonide. Okay, so this benzene triazonide, what happens to benzene triazonide when it is hydrolyzed? So when it is hydrolyzed, treated with water, then it produces, again I can give four options. Okay, it produces water as the side product, or hydrogen as the side product, or oxygen as the side product, or hydrogen peroxide as the side product. So your answer has to be hydrogen peroxide. So that's why you have to learn this reaction in detail. Okay, so for this case, if it is possible for you to remember, it is possible for you to remember the equation. It is very good. Okay, the equation you'll find in your textbook also. The addition of ozone to benzene with regard to the what you call structure of benzene triazonate, that you go through it from the textbook also. It is, you'll find a textbook somewhere around 809 or 10 page number. Okay. Then after this, I just want to ask you one few questions on the screen. Okay, if you can see the screen, you may take a snapshot of this page which is on a screen. Which one is more acidic? This is one question. Which one is more acidic? Okay, this is question number one. Then question number two is here. Question number two. Which one has a lower boiling point? Which one has a lower boiling point among these two? Okay. This is for you all to find out the answer. Okay. I will not give the answer just now. Okay. To find out the answer from here and there from the textbook, because this could be a part of your MCQ second term examination. And the third question is here. The third one, complete the reaction. We are using halogen acid over here, remember. And there is an unsymmetrical alkene. So complete this reaction following a certain rule which I have taught you, which is called Markovnikov's rule. It is called Markovnikov's rule. Okay, applied over here. And same thing here also. That is question number 4. Complete the reaction. So when vicinal dihalides are reacted with alcoholic potassium hydroxide, so here what is the product which is formed? So complete this reaction. So these are some 4 important questions whose solutions you have to find out and get the answer. It is important. Okay. Now after this, moving to the next slide, I think you can solve these questions. If you get the answers, send me the answers in the what you call personal WhatsApp, in the personal WhatsApp number, so that I can check. I can tell whether the answer is correct or whether the answer is wrong. Okay. And if it is wrong, why it is wrong, I'll tell you. Okay. If it is correct, why it is correct, I'll tell you that also. Okay. So whenever you attempt to answer any questions, always try to back up the answer by a proper plausible reasoning, probable reasoning. Then only it is better. Okay, because you are in class 11, you have to make sure that your answers are backed up always with reasoning. Okay. Now moving to the next slide on your screen, this is the last slide for today to complete this chapter, hydrocarbons. Okay, this is one slide which I got with a lot of difficulty. So here if you see very carefully, everything is summarized in one page only. Okay. Benzene over here in presence of nickel, it is producing cyclohexane. With acetyl chloride in presence of anhydrous aluminum chloride, is giving acetamide, SuCH3, acetophenol. With chlorine presence of aluminum chloride, chlorobenzene. With 6 molecules of chlorine anhydrous in the dark, it is producing 6 chlorine atoms, benzene substitution, deadly substitution. With 3 chlorine molecules, it is forming BHC, ganaxine. With methyl chloride in presence of aluminum chloride anhydrous, is producing toluene, methyl benzene, then benzene sulfonic acid. Okay, so this will become a very important slide for you all to learn this today for a happier tomorrow in organic chemistry. Okay, learn this chart properly. Okay, this has been discussed already in the previous slides in the previous classes. Okay, one or two may be new. Okay, but Nevertheless, this one is combustion, what do you call oxidation. This one which you see, this part is oxidation of benzene. Okay, so here and the presence of UV light temperature of so much, the presence of oxygen is producing, burning down with a sooty flame to give carbon dioxide and water. Okay, so with this we come to the end of this chapter. Okay, and tomorrow uh, is Friday. I will take class tomorrow. Okay, in the same time from 12 o'clock to 12:40, and tomorrow maybe possibly I will discuss some important questions from this chapter. Important question from this chapter which can be asked for your second term examination. Okay, so just hold on. Let me record the attendance. Okay, and then
Sir,
yes,
sir, will all the question be MCQ type this chemistry
yeah,
exam?
yeah, yeah, yeah. All the questions will be MCQ. All the questions will be MCQ. Okay,
So we have to show the working.
for the working, you do the working in your what do you call in your exercise copy, and at the end, at the end, I'll send the link separately to upload all the
Yes, sir.
working for that. Okay, separately. There'll be a separate link to upload all the working. Okay, but you have to show the working. But in the working, be neat and tidy. Write down the question number. That is question number 15, 16. If you don't write the question number, I will not know this working is for which question. So that means I cannot give you marks. No? It's very important that you show the working. Do the working and select the correct answer. Okay, so I don't know your chemistry exam. I think it's on the 25th of September, if I'm not wrong. Please confirm with the school's website. Okay, for the routine. Okay, it must be on 25th of September only. Okay, so now I would like to record the attendance before you leave the class. Okay, just a second. Uh, mm, Okay, the attendance is being downloading. Okay, it's downloading. It's downloaded now. Thank you so much, boys. Have a nice day.
Thank you, sir.